If you watch enough Hollywood action movies, you really start to internalize this very specific illusion about how emergencies work.
Oh, yeah. The classic action hero trope.
Exactly. I mean, you picture the hero, right? They're sprinting down the smoke-filled hallway. They spot the locked door standing between them and the trapped victims. And what do?
They definitely don't stop to think about it.
Right. They don't even slow down. They just launch into this flying kick. The door explodes off its hinges in a shower of splinters, and they just burst into the room to save the day.
It's pure cinematic gold. I mean, the sheer kinetic energy of it really sells the urgency of the moment. We expect heroes to conquer obstacles through pure, unadulterated willpower.
But today, we're going to completely shatter that illusion. So welcome to this custom-tailored deep dive designed specifically for you, the listener. Because today we're looking at the stark, meticulous reality of how professionals actually break through locked doors.
And it is a fascinating reality to dig into.
It really is. We've got a great stack of source material to get through today. We are looking at a highly detailed grading rubric and cheat sheet for a firefighter's forcible entry exam.
Specifically focusing on the protocol for inward swinging doors.
Yes, exactly. And our mission for this deep dive is to really deconstruct this high-stakes choreography. We want to understand how these professionals systemize chaos and, why, in a life or death scenario, they prioritize methodical safety over that Hollywood brute force.
It's a remarkable piece of source material to analyze, honestly, because, well, it outlines an operation that is strictly capped at 4 minutes and 40 seconds.
Wow, less than 5 minutes.
Yeah, that is the absolute maximum execution timeline. Under 5 minutes to do something incredibly complex mechanically, all while wearing, 80 pounds of heavy gear in an environment that is actively trying to kill you.
Okay, let's unpack this, because the very first thing that jumped out at me from the exam protocol is that the test doesn't actually start at the door.
Right, the clock is ticking before you even make contact.
Yeah. You aren't just standing in front of a piece of wood with an axe, waiting for a starting pistol. The timer begins with this intense psychological and physical setup that they call command presence.
It's a critical phase. The first 30 seconds are entirely about establishing control.
Right, and it's wild to read. The firefighter has to approach the examiner, confirm their assignment out loud, and verbally state they are grabbing their primary forcible entry tool, the Halligan.
Which, for those who don't know, is a specialized multi-purpose prying tool.
Yeah, exactly. And they grab that along with a striking tool, the flathead axe.
Yeah.
But here's the part that really got me. The protocol mandates retrieving a utility rope, and it explicitly requires pulling it from the right bunker pocket.
Yes, the right pocket specifically.
Does it really matter which pocket the rope is in? I mean, if a building is burning down and you only have 4 minutes, failing someone because they use their left pocket seems, absurdly rigid.
It sounds arbitrary on paper, sure.
And on top of that, they are required to constantly narrate their actions using these continuous I am statements like, I am selecting a Halligan. I am retrieving my rope from my right pocket. It feels like a pilot running through a pre-flight checklist.
Exactly like a pilot.
But doing it out loud while sprinting full speed toward a disaster.
Well, what's fascinating here is that this continuous verbalization, this command presence, isn't just a performance for the examiner to grade.
It's not just checking boxes.
No, not at all. It serves a profound neurobiological purpose. It anchors the firefighter's cognitive focus.
Oh, interesting.
Yeah, because when you're responding to an active fire, your body is just flooded with cortisol and adrenaline. Your amygdala, the primitive alarm system of your brain, is screaming at you to act instantly.
To just smash something.
Exactly, to succumb to tunnel vision. By forcing the firefighter to speak out loud, to formulate the words, I am doing this specific action, it literally forces the brain to stay engaged in the prefrontal cortex.
Which is the logical part of the brain, right?
Yeah, right. The logical, organized, higher-level thinking center. You cannot speak in complex, structured sentences and be in a state of blind panic at the exact same time.
So you're basically hijacking your own brain to stay calm.
Precisely. You are overriding the panic response. And as for the right pocket, under that kind of severe physiological stress, humans lose their fine motor skills.
Oh, and short-term memory recall, I'm guessing.
Yes, exactly. You do not want to be standing in a hallway that is rapidly filling with black smoke, patting yourself down like you lost your car keys.
Oh, man. Yeah, that paints a terrifying picture.
You need absolute, Unbreakable muscle memory. The rope is always in the right pocket, so the hand goes there automatically. The brain doesn't need to spend processing power on the decision.
Wow. Okay, so you've controlled your mind, you've gathered your tools, and you're making your way forward. But even getting to the door isn't just a simple walk down a hallway.
Not at all. The approach is highly tactical.
Right, I noticed the exam strictly requires them to approach the door from the windward side if they're operating on an exterior door. They actually fail if they don't use the wind to their advantage.
Because the firefighter is actively reading the environment before they ever even touch the obstacle. Positioning yourself with the wind at your back is vital for environmental protection.
Because it blows the smoke away.
Exactly. You are keeping the intense heat, the toxic gases, and the blinding smoke blowing away from your mask rather than letting it engulf you.
Makes sense.
And simultaneously, that verbalization we talked about continues. They have to state, I am evaluating the building for fire conditions and possible backdraft indicators.
Right, so they are looking for smoke pushing through the cracks under pressure or windows getting dark and oily.
Yes, those are key warning signs.
But there's a step before they even touch the doorknob that really surprised me. They take that rope from the right pocket and they tie a figure-8 knot to the door handle.
The door control leash?
Yeah, they literally put a leash on the door. I'm guessing that ties directly back to the backdraft indicators they were just looking for.
It does, absolutely. See, a locked door in a burning building isn't just a piece of wood. It is a dam holding back a lethal, pressurized environment.
Oh, damn.
A fire inside a closed room will rapidly consume all the available oxygen. Once the oxygen drops below a certain threshold, the visible flames might actually die down.
Really? The fire goes out.
It looks like it. But the heat remains immense. The room fills with superheated, unburned gases, carbon monoxide, vaporized synthetics, all just baking in there at over 1,000 degrees.
Just waiting for a breath of fresh air.
Yes. The room is effectively a powder keg that is starved of its trigger. If a firefighter forces that door open without controlling it, the sudden influx of oxygen rushes in, mixes with the superheated fuel, and ignites almost instantaneously.
And that's a backdraft.
That is a backdraft. It is an explosive ignition that will blow back through the doorway with the force of a bomb.
Unbelievable.
So, securing the door with that rope and a figure-8 knot gives the firefighter mechanical door control. If you crack the seal and the pressure tries to violently throw the door wide open, that rope stops it.
You can just pull it shut again.
Exactly. You maintain the ability to pull it shut and cut off the air supply.
Wow. Okay, so here's where it gets really interesting. Because the physical interaction with the door is treated with the exact same caution as diffusing an explosive.
It has to be.
They step up to the threshold, and the protocol dictates they must pull their glove down, exposing their bare skin, and sweep the door for heat.
A very specific sweep, too.
Yeah, they must use the back of their hand, not the palm, moving in a precise Z pattern from the bottom of the door to the top.
And every single one of those microactions is rooted in survival biology and fluid dynamics.
Okay, I need to know why. Why the back of the hand?
Think about the mechanics of the human hand. The flexor tendons, the ones that close your fingers into a fist, are incredibly strong. If you touch a superheated metal door with your bare palm and sustain a severe instantaneous burn, the muscles and tendons react by violently contracting.
Oh, I see where this is going.
Your hand will naturally curl up into a permanent damaged claw. You can no longer grip your Halligan or your axe. You are out of the operation completely.
But if you use the back of the hand...
If you burn the back of your hand, it is excruciatingly painful, yes. But the flexor tendons are safe. Mechanically, your hand still functions. You can still wrap your fingers around the shaft of your tool and swing it.
That is intensely practical and brutal.
It is the reality of the job.
So they sweep in a Z pattern. I'm guessing that's not random either. Does it have to do with how the heat is moving inside the room on the other side?
Spot on. Fire behaves like a fluid. Heat rises and gases stratify in a burning enclosure.
So it's hotter at the top.
Much hotter. The floor on the other side of the door might be relatively cool, maybe 80 degrees, while the ceiling is banking down toxic heat that is 600 degrees. By sweeping from bottom to top in a Z pattern, the firefighter is feeling for the exact location of that thermal layer. They are mapping the invisible environment on the other side of the wood.
That's brilliant.
If we connect this to the bigger picture, these aren't just arbitrary rules designed to make a test difficult. These micro-actions represent vital layers of risk mitigation, turning a blind obstacle into a known quantity.
And right after this incredibly intense scientific assessment comes a step that is hilariously simple.
Oh, the handle check.
Yes, the firefighter must say out loud and physically do, "I will try before I pry." They just turn the handle to see if it's unlocked.
It sounds like a joke to civilians, but it is a critical failure point on the exam.
It's just wild to picture a fully geared firefighter, pumped up on adrenaline, wielding an axe and a steel prying tool, spending 5 minutes aggressively destroying a commercial steel door, only to find out it was completely unlocked the whole time.
But it happens. Tunnel vision is a powerful enemy. You have your heavy tools, dispatch gave you an order to force entry, you see a closed door, and your stressed brain just skips a step.
You just assume the obstacle is locked.
Exactly. And forcing an unlocked door wastes precious cardiovascular energy, it destroys property unnecessarily, and most importantly, it wastes time that victims do not have.
Right, every second counts.
The protocol literally forces them to check their assumptions before committing to violence. Try before you pry.
Okay, let's assume the handle doesn't budge. The door is officially locked and secured. Now we transition to the actual breach, the physical breaking of the barrier.
This is where the heavy tools come into play.
Right, but first the firefighter checks for through-the-lock options. The exam mentions using a K tool or an A tool.
Right. A through-the-lock method is a surgical approach to forcible entry.
Surgical how?
Instead of destroying the heavy door itself, you target the weakest link, which is the lock cylinder. Tools like a K tool have shaped metal blades that slide down over the face of the lock cylinder. You tap it into place with your axe so it violently bites into the metal of the lock. Then you use your Halligan tool as a lever to pry the entire cylinder straight out of the door.
Oh wow, so you just rip the core out?
Exactly. Once the core is ripped out, you just slide a small key tool into the empty hole, trip the internal mechanism, and open the door normally.
But the clock is ticking, and sometimes the cylinder is armored or recessed. The exam protocol accounts for this. The firefighter states, "Through the lock method is not feasible. I will proceed with conventional forcible entry. We are going through the door."
And this is where the geometry and mechanics of the space become paramount. The firefighter must position their body using the adjacent wall for protection.
Oh, to stay out of the doorway.
Right. You never stand squarely in the kill zone directly in front of the door you are forcing. If the hinges give way outward, if a backdraft occurs, or if a hostile individual on the other side fires a weapon through the wood.
You want the solid wall taking the hit.
Exactly. You make your profile as small as possible.
Now, the strategy here shifts completely depending on the architecture. The cheat sheet emphasizes a massive difference between an outward swinging door and an inward swinging door.
It dictates the entire mechanical approach.
For an outward door, one that opens towards you like a utility closet, the memory trick is pull and separate. You're pulling the door towards you, breaking the seal from the frame.
Yes.
But our specific scenario today is an inward swinging door. It opens away from you into a bedroom or a hallway.
And the memory trick for the inward door is break and push through. You aren't pulling, you are working your energy into the structure.
Okay, so how do they do that?
The firefighter inserts the adze, which is the flat wedge-like blade at the top of the Halligan tool, between the door and the jamb, right near the locking mechanism. They strike it with the axe to drive it deep into the gap.
Wait, hold on. Step 10 specifically instructs them to, quote, make short pries to separate the door and jam to create an access window.
Yes, short controlled movements.
But if I am on a ticking clock and someone is trapped inside, why am I wasting time with short pries? Shouldn't I just plant my feet, grab the end of the Halligan, and use every ounce of muscle to crack it open in one giant shove?
That goes right back to the Hollywood illusion we talked about. Relying on a single massive heave is relying on blind strength. And blind strength is dangerous and, frankly, inefficient.
Dangerous how?
Well, if you overextend early and put all your body weight into a massive pry, what happens if the metal tool slips out of the jam?
Oh, you'd go flying.
You lose your balance, you fall violently against the door, or you tumble backward into the hallway. What if the heavy steel door frame flexes, but the deadbolt holds?
You've spiked your heart rate for nothing.
Exactly. You've exhausted your muscles for zero progress.
It's like trying to open a stubbornly sealed paint can.
Oh, that's a great comparison.
If you jam a flathead screwdriver under the lid and heave with all your might on the first try, you either bend the screwdriver or you warp the lid so badly it gets stuck worse. You have to work the tool millimeter by millimeter around the edge.
That is an excellent analogy. You are aiming for mechanical dominance over the object. When dealing with a heavy commercial door, it's like trying to move a fully loaded refrigerator by yourself.
You definitely don't try to bear hug it and lift it.
No, you rock it, shift its weight, and walk it forward inch by inch. Short controlled pries maintain your leverage. You create a small gap. Then, the protocol states you alternate the fork end of the halligan, the two curved prongs at the other end of the tool.
Okay.
You systematically pry, capture the progress, push, capture the progress. You are walking that metal latch perfectly past the keeper in the door frame. You are managing the kinetic energy.
It's not about being the strongest person in the room.
Exactly. It's about being the smartest person with a lever.
Wow. Okay, so I am alternating the fork end to pry and push the door until the lock clears the keeper. Click, pop. The latch grunts the frame, the door is forced, it swings inward, the breach is successful.
The obstacle is cleared.
Now, human instinct, at this exact second, has to be screaming at you to drop your tools and rush inside. The barrier is gone. Time to go save whoever's in there. But if you cross that threshold right now, you instantly fail the exam.
This raises an important question, doesn't it? What actually defines the end of this operation?
I mean, getting the door open, right?
In the mind of an amateur, the goal is an open door. But in the mind of a professional, the goal is a safe point of entry. Those are two very different concepts.
The final sweep. Step 12. Before stepping inside, the firefighter stays in the hallway. They maintain physical control with that utility rope on the handle.
Yes, maintaining that door control.
They must visually sweep the area inside for debris, for victims who might be slumped directly against the back of the door, and for immediate fire obstacles. And crucially, they must perform an action called sounding the floor.
Because you cannot trust a floor in a burning building just because it looks solid through a thick layer of black smoke.
It could be totally burned out underneath.
The fire could have been raging in the basement or the room directly below for an hour, entirely burning away the structural floor joists.
So how do you sound it?
Sounding the floor means striking the floorboards firmly with the heavy head of your tool before you commit your body weight to it. You are listening to the acoustics, sure, but more importantly, you are feeling for the structural feedback traveling up the fiberglass handle of your tool.
You are feeling for a solid thud versus a hollow, spongy vibration.
Exactly. A solid floor stops the kinetic energy dead. A compromised floor feels like hitting a trampoline.
Oh, wow. That is terrifying.
It bounces back softly. If it sounds hollow or feels spongy, you do not go in. The open door means absolutely nothing if you fall through a collapsed floor into a basement fire the moment you step inside.
The amount of discipline required in those final 20 seconds is just staggering. And, looking at the common failure points section of this cheat sheet really highlights how unforgiving this exam is.
It is incredibly strict.
People fail for saying actions out of order, like trying to force the door before completing a heat check. They fail for forgetting the windward approach or failing to check their assumptions by skipping the try before you pry handle check.
Or simply mixing up the mechanics under pressure.
Right, under the crush of the 4-minute timer, mixing up the inward and outward door dynamics, pulling the tool when they should be pushing it. It is entirely a test of mental fortitude holding up under immense physical exhaustion.
It really is.
So what does this all mean? We've just spent this time walking through 4 minutes and 40 seconds of a very niche, highly specialized examination. But I look at this timeline and I realize there is a massive lesson here for you, the listener, regardless of what you do for a living.
Oh, absolutely. The principles transfer completely.
Whether you are prepping for a high-stakes boardroom confrontation, managing a massive project rollout that's going off the rails, or just trying to navigate a sudden crisis at home, the lesson from these firefighters is crystal clear. True expertise isn't about rushing in. It isn't the Hollywood flying kick.
No, true expertise is the methodical deconstruction of the problem. It is securing your environment before you act. It is checking your assumptions before you commit to destruction.
Try before you pry.
Yes. And it is applying controlled, incremental leverage to your obstacles rather than exhausting yourself by throwing brute force at a problem and hoping it breaks before you do.
I think my favorite takeaway is the absolute refusal to rely on blind panic.
I think there's a final lingering thought here that ties perfectly into that, going back to the very first concept we discussed, command presence.
Right. Talking out loud.
The strict requirement to constantly verbalize actions with I am statements to prevent the amygdala from hijacking the brain. If highly trained professionals use out-loud, deliberate narration to force their brains to stay logical and methodical when they are surrounded by literal fire and toxic smoke,
Yeah,
it makes you wonder about the metaphorical fires in our own daily lives.
well, that's a great point.
When we face a moment of deep anxiety or a high-stress confrontation at work, our instinct is to internalize that panic. We let the chaos swirl silently in our heads, which only fuels the physiological stress response.
It just makes it worse.
What fires could we extinguish in our own lives if we simply stopped, took a breath, and started narrating our reality out loud? Stating objective facts aloud literally re-engages the prefrontal cortex, cutting through the noise and stopping the panic in its tracks.
The next time I find myself completely overwhelmed by a crisis, I'm going to try exactly that. Grounding myself in the physical reality of the next logical step, out loud. Well, that is all the time we have for today. We hope this exploration into the mechanics of forcible entry gave you some surprising insights, not just into a fascinating and dangerous profession, but into how to methodically dismantle the locked doors in your own world. Thank you for joining us on this deep dive, and as always, keep exploring and stay curious.